Just to look at the use of embedded system. So embedded systems are used in different ways, and one of the use of embedded system is it is controlling some components of a car. So in modern car have various parts that rely or are based on embedded systems to function correctly or to work properly. Some of the components that are controlled using embedded system in a car are shown in this picture. A car can be using embedded system in car entertainment system, GPRS system, airbags, fuel injection system, ABS braking system. It can also be used in security system, can also be used in exhaust emission, and also traction control. So those are various areas of use of embedded system in a car. So as you can see, there are many components of a car that is controlled by embedded system. So especially in sport cars and those currently being that are currently being used, there are so many components that are being controlled by embedded system is used in a car. Embedded system can also be used in a set-top boxes. So for instance, a set-top box uses embedded system to allow for recording and playback of television programs. So this can be done or remotely by user when the user is not in the current place where the embedded system is installed, meaning you can control this remotely if the set-top box is normally at home. So you can record your program that maybe happens when you are not at home. So you can use a set-top box to record this program and use it and probably watch that program when you come back home. So some of these embedded systems are very special in that they can be controlled remotely and be useful for you when you arrive home or when you get back to the location where your embedded system is actually installed. Now the embedded system has got various components. Like say for instance, when we are talking of this set-top box, it has got the front end, then there's also the interface. There is RAM, there's the front panel, and then there is solid state devices where the programs are actually stored. So this diagram that we have right here is basically there to demonstrate how the embedded system or a set-top box which is considered an embedded system has got various components and how they work. So you can see that there is interface which included HDMI output. There can also be interface which is based on analog output. So those interfaces are very important to be there, and we need to know that these interfaces are made of various standards and different standards. So they come in different ways and in different forms. Now we also have front end, which consists of the aerial, the cable input, and the satellite input. Now this is what is capturing signal from the environment, probably through which the signal that you are using from, or the one that you are sending from where your remote location will be captured through this front. And then we have the SSD or solid state drive, which was the programs. So that is it. So that's how a set-top box is configured, and in a nutshell, that is how it looks like from this diagram that we have right here. Now we also have use of embedded systems in security systems. So it can come in this way. This is basically embedded system found in a security system. So if you look at this picture, it clearly demonstrates or shows you how security system in an embedded system which uses embedded system look like, and it stipulates and shows you the devices that are there, that are connected, that are working together through the controller, which is able to coordinate all these activities. So there is a solid state drive, there is random access memory, there is sensor for input, and also basically there are bunch of output which is able to relay that information either to you at your remote location or just right within the house if there is any security breach. So the input is basically the sensor, which is able to capture movement of people around or even on the windows or the door. So if any pressure is dictated on the door, the system will be able to process that and send you some information. So this data that is captured from the environment can be stored in RAM. Then this data can be checked or can be compared against the one that is already existing, which has been stored on solid state device, to see whether they marry or they are contradicting, or basically to there are processes that we compared so that you as a user can be given some feedback to take the necessary required action in countering that breach of security that you might have. Now we also have lighting systems being controlled by embedded systems. So embedded systems are used in modern light system, from simple home use to major architectural lighting system. So let us look at how this lighting system is being used, especially if it is utilized in a specific area. Say a large office. So there's the lighting taking into account the following system: the time of the day of the week, whether the room is occupied, where the brightness of the natural light is okay. So an embedded system can automatically control light using the input, which in this case are sensors, which fit well into the figure. So there is a figure which 3.6. There is a figure here we talked about the figure 3.6. Okay. So there is a figure that we are being referred to, but that one is not important as what we are looking at the moment, but it's just a reference point. So the time of the day of the week is important in an environment, since energy is saved if the same switches to low levels when occupied. So time of the day is very critical. like maybe toward at the end of the day when it is getting dark, you see, will not have much light, so the system will be required to sense that and adjust accordingly. Or very early in the morning when it is still dark, there is no much light, so the system is able to adjust itself accordingly to allow the right maybe to allow the system to control the lighting of the room in terms of augmenting or actually increasing the intensity of light, or basically to increase the light so that there can be enough light in the room for those people who are working in that room. So this is a way of a way in which embedded systems are being used. And as you can see in the story that is given here, we are told an embedded system can automatically control lighting using a number of inputs. So one of the inputs is sensors. So key data, the data that has been keyed in is stored in the computer memory. Again, this fits very well in the system described in figure 3.6. So the time of the day of the week is important, that in an office environment, since energy is saved if the system switches to low lighting levels when occupied. This can be overridden by the second bullet point above. If there is a movement in the office, then the correct lighting levels will be automatically restored. On a very bright sunny day, the system could automatically dim the light, only increasing the light output if natural light levels fall below a set value. So there are many internal and external lighting systems that could be controlled by embedded system. A fountain line display or a light show on a building to commemorate a special occasion. So they are also used to trigger emergency lighting if, for example, aeroplanes in case of aeroplane emergency. So some lighting systems use Bluetooth bulbs. This allows the embedded system to control each bulb independently, and many of the bulbs available today use light emitting diodes, and many come in a number of colors to change the mood. So that is the description that is given there, which we had already explained before. So technically, that is how embedded system can be used in those areas. So there are also different areas where embedded system can be used. The embedded system can be used in a vending machine. Embedded system can also be used in a washing machine. So those are some of the use of embedded systems. So I think it is important to note that these systems are very useful to us in the environment, because they've been able to change how we maximally use the natural light, and how we also leverage that and use economically the light that is generated by electricity. So in that we are able to save energy and not waste a lot of light energy to the environment. So it is clear that embedded systems are very useful to us. Now, another area where embedded system is used, we've mentioned, is found in vending machine. So they usually use microcontroller to control a number of functions that we all associate with in a vending machine. So there is a sensor to make sure that machine is not tampered with. So if somebody try to tamper with the system, like to break it down or to try to, the system is going to generate some noise. There's input pad where you can be able to press so that the information can be captured, and whatever you want or whatever data you key in is processed by the microcontroller. There's sensor to show the position of the gates which holds the items, and also if the dispensing row is empty, so there's a sensor for that. There's coin counter to ensure correct amount is entered. The temperature of the sensors to help maintain correct environment of the items. There are also actuators which control the motors that are there, which control the motors that are there. There's also the displaying of the price, which is also being controlled by the microcontroller. Then there is also the wireless modem to send data back to the vending machine operator. So those are from this diagram you can be able to see all the functions that are normally associated with the vending machine. So these are very important devices. So also washing machines use embedded system or are controlled by embedded system. So we also have what we call microwaves, which are also embedded system controlled. So there are so many areas where embedded system can be applied. So thank you for taking your time and understanding with me this concept of use of embedded system. So till we meet again, remember to subscribe, and we develop this channel together. Thank you.